Hello and welcome to SudoKanard. Recently, on the Cracking the Cryptic fan server on Discord, there was this speed setting contest organized by Punching Cato, and it was about creating a Skyscrapers puzzle with zeros, meaning that some digits, you use the digits, let's say 0 through 6 in this 7x7 grid, instead of 1 through 7. And 0 is not a building, it's just a wasteland or something like this. And so it's not counted in the visible buildings by the outside clues. So this is what I came up with in the limit of 1 hour. I had to put this given digit as a last result to ensure uniqueness, but it finally worked, and I'm about to walk through this puzzle, and I just hope I'll be able to solve it again. So where do we start? Well, those 3 5s are here for a reason. That's where I started the setting. And why is it so? We have digits from 0 to 6, so on each row only one building is hidden, meaning that those digits can't be 3 or more, because 3 would hide 2 buildings. So there must be at most 2, which makes these cells a 0, 1, 2 triple. And obviously the other cells in this column must contain 3, 4, 5, and 6, but I won't pencil mark them, as it would well, you see what I mean. Let's move on with this column, with those 3 rows, sorry. We need to put 6s, obviously, but we won't put them here, because 6 is the tallest building, and if I put it here, then I won't see more than 4 buildings, and I won't see more than 3 if I put it here. So these cells can't have a 6, and the 6s in these rows must be in those cells. And the interesting fact is that we have constrained 6 to be in these cells. So we know that the 3 6s in those 3 columns will be here, and there are no 6s anywhere in the other cells. Well, in most cells it would have been impossible for other reasons. Like this 4 says that 6 must be at least in the 4th cell. So that's the point. And this 3 forbids 6 from being here. And let's have a look at this one. This one says that we only see building 6. And it won't be here. It has to be here. Because if I put it here, then I see other buildings. And because 6 is the only one that is seen, this must be a 0. And now we know that 6 must be in those cells. And I just remove the crosses. Some interesting facts is that one of those will be with a clue of 4, which means that the digits will have to be in ascending order in one of those columns. Speaking of ascending order, this 5 now becomes restricted, because we know that we see 5 buildings here, so this one can't be a 0, and those 5 digits must be in increasing order. So those are the options. And this 5 will be fulfilled, whatever our choices of digits here. And this one is fulfilled. This 2 now places a 5 here. It has to hide all other buildings. and 0 has already been located. Those 3 cells must have 1, 3, and 4. And then, then let's have a look at what happens with 5s on these rows. Something similar to what happened with 6s happens with 5s. Namely, that 5 can't be in those cells, because if 5 is here, then I see at most 3 buildings, this, the 5, and the 6. And if I put 5 here, I see at most 4 buildings. And those 5 clues would be broken. So the places for 5s in these rows are those here. And what do we do with this? Well, the interesting stuff here is that if I put a 5 here or there, then I break these two. Let's imagine I put a 5 here. Then 6 has to go down. And this is a real digit, it's a real skyscraper, a real building, and then we see at least 3 buildings. And if I put 5 here, 6 is in either of those cells, and I see 3 buildings because of this 0. So 5 can't be in either of those. 5 has to be here, and it places this 6 and the other 6 here. And so we need a 5 here or there, and a 5 in one of those 2 cells. This 4 now, as I mentioned earlier, means that we see 4 buildings, and 4 real buildings. There's no 0 here. And there's no 0 here either. So 0 must be in one of those 2 cells, and we get a 0-5 pair here, which means that whatever building I put here, this 3 will be fulfilled. And here we get an ascending set of digits culminating at 4. So it must be 1 or 2, 2 or 3, 3 or 4. And this one can be any digits between 1 and 4 right now. Well, where should I look next? This or that? What's up in here? Where should I look? That's always the question. That's really the question. What could go here? Could a 4 be here? Let's imagine there's a 4 here. Then this is not 0. It has to be 1, 2, or 3, and we see 3 buildings. So 4 here wouldn't work. And it means that in this row, 4 is here or there. So what can I have here? I will have at most 3. So it must be 0, 1, 2, or 3. And with the 0, anything here would work. And this now must be any digit between 1 and 4. Let's have a look here. What can go into this cell? I'm missing something here. Let's have a look at this column, because this 4 says that this can't be more than 3. With a 4 here, I would see at most 3 buildings. And it's not a 0, so it has to be 1, 2, or 3. Now, those cells also can't be more than 3, because with the 4 here, I would see at most 4 buildings in this row, same here. So those can't be more than 3. And we have a 0, 1, 2, 3 quadruple here. So the remaining digits here must be 4, 5, and 6. And something else that is important is the positions of zeros on these rows. Because on those columns, we know because of this triple that 0 is here or there, and on this column that 0 is here or there. So we have either zeros on this diagonal or zeros on this diagonal, but we have 2 zeros here, so 0 can't be here. And this now has to be a 5. I get this 0 here, removing 0 from this cell, and this 5 puts a 5 here. Now on this row, 4 can only be in this cell. And now this building here must be bigger than this one, so it has to be 2, 3, or 4. And here, sorry about that, here we must see 4 buildings, and we know that 0 is somewhere. So the non-zero buildings must be in ascending order. So we have 0, 1, or 2 here. 0, 1, 2, or 3 here. 0, 3, or 4 here. That's it. So it can be a 1 here with a 0 here and a 3 or 4 there, etc. This one could have caught my attention much earlier. Oh, I can say that this 4 is fulfilled. This one could have caught my attention earlier, as it means that only building 6 will be seen, so 6 must be in one of those 2 cells, and in case 6 is here, then this has to be a 0. So this is 0 or 6. And now that we have a 6 here and a 5 there, let's think of what happens. Here we must see 4 more buildings, and there's a 0 somewhere, so the non-zero buildings must be in ascending order, meaning that this can only be a 4. And now 3 must be in one of those 2 cells, so it can't be here. And this can't be a 2 because it would hide the 1, and 1 is not to be hidden. And there has to be a 3 here, and this can't be a 1 or a 2, so it has to be 0 or 3 and 0, 2 or 3 here. This case, this row looks to be a little trickier, but 4 can only go here. This one will be fulfilled for sure. This 2, well, that's just something to say, I think. Now let's think of this 4. I'm not sure about that. Is it this 4, or this 3, or this 4? Where should I look next? Well, in this row, exactly one digit, one building will be hidden, and this one is hidden, which means that the real digits that appear here must be in ascending order, and one can't be here. Oh, something I'd forgotten about. As I mentioned earlier, here we have zeros on this diagonal or on this diagonal, so we can remove 0 from these other cells. And now this 3 gives us those eliminations. And here. Nice. Well, let's write these two more to make it more readable. So more eliminations. And let's have a look. This 5 clue is fulfilled. And here, oh, this one gives more eliminations as well. And this 5 is fulfilled. We see the 2, 3, 4, 5, 6. Then let's have a look at this cell. 2, 3, 4, 1, 5. This can only be 0 or 6. So I get a 0, 6 pair here, which eliminates 2 here. 6 here, and I get a 3 down there, and this 2 eliminates 2 from this cell. Alright, now let's have a look at this 4. 3 can't go here because we would see at most 3, 5, 6, it would make 3 buildings, so I can't have a 3 here, and in the column it can only be here. This 2 now makes this a 1, that's a 0. I get this 2 and some more eliminations. Now to fulfill this 4, 1, 3, 5 and 6, that's the only way. Here on this row, well, this can only be a 6 now, and to fulfill this 3, this has to be a 4, because 3 would allow us to see the 4, the 5 and the 6. So that's a 4, that's a 3, I get this 4 on top, this 2 is fulfilled, this 4 is, this one is as well. Now, what do we have? Well, we have a lot of forced digits. This one is a 3. That's a 5. That's a 4. That's a 1 now. That's a 5. That's a 6. That's a 0. I get this 2, this 6, this 1, and a 0 to wrap it up, and this 4 is fulfilled with 2, 3, 5 and 6. So this finishes the solve of this sorry about this, I'm getting distracted. So this finishes the solve of this Skyscrapers with the zeros puzzles that I created, but well, as you see, it was kind of tricky, and I had trouble putting all together again. Thanks for watching this video, and see you soon on SudoKanard.